A chemical change is a particular kind of change. In chemical changes, two or more kinds of material combine with each other to produce entirely different materials. A chemistry laboratory is not the only place where you can see chemical changes taking place. In fact, the most common and important chemical changes are going on all around you. Burning is a common chemical change. The wood changes into different materials: smoke, steam, and ashes. The growth of plants depends upon chemical changes. Air, water, and soil combine to produce roots and leaves. Chemical changes inside your digestive system change the food you eat into the materials that build your body. In fact, all life is dependent upon many complex chemical changes. In order to understand what a chemical change is, we have to understand what materials are made of. Water is a common material. Let's see what it's made of. If we could look at it closely enough, even more closely than we can see with the most powerful microscopes, we would see that water, like all materials, is made up of small particles called molecules. If we could look still more closely, we would see that each molecule is made up of still smaller particles called atoms. This is a model that represents a molecule of water. A water molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. Every material in the world is made up of its own kind of molecules. Each molecule, in turn, is made up of certain kinds of atoms. Now, let's see what happens to atoms and molecules when a chemical change takes place. This material is called mercuric chloride. A mercuric chloride molecule is made up of 1 atom of mercury and 2 atoms of chlorine. This other material is potassium iodide. A potassium iodide molecule is made up of 1 atom of iodine and 1 atom of potassium, which is a type of metal. Now we'll dissolve the mercuric chloride and the potassium iodide in water. When the 2 solutions are mixed together, a chemical change takes place, and new materials are formed. This mixture has changed color because it contains a new material which is orange-colored. This material is called mercuric iodide. Its molecule is made up of 1 atom of mercury and 2 atoms of iodine. When we mix the 2 materials together, iodine from the potassium iodide molecules replace the chlorine of the mercuric chloride molecules, forming molecules of mercuric iodide. A chemical change takes place when atoms from the molecules of 2 or more materials join with each other to form molecules of entirely different materials. Let's watch that again. Iodine from the potassium iodide replaces the chlorine of the mercuric chloride, leaving molecules of an entirely different material, mercuric iodide. Here's another chemical change. When a piece of wood burns, many of the molecules that make up the wood combine with oxygen molecules from the surrounding air to produce molecules which form new materials that are neither oxygen nor wood. We can't see the oxygen that's used in this chemical change because it's a colorless gas. But if the supply of oxygen were cut off, the burning would stop. This jar cuts off the supply of oxygen from the candle flame. When there are no longer enough oxygen molecules left inside the jar to continue combining in the chemical change with molecules from the candle, the flame goes out. Fire is one of many chemical changes which produce energy. A fire gives off energy in the form of light and heat. Here's another kind of energy, also the result of chemical changes. Chemical changes inside your body combine the food you eat with the oxygen you breathe to produce energy. When you need extra energy, you breathe harder in order to get more oxygen molecules into your body to be used in these chemical changes. When you exhale, you breathe out a gas called carbon dioxide. Carbon dioxide plays a vital part in one of the most important of all chemical changes. This chemical change takes place in the green leaves of growing plants, but only when energy is present, in the form of sunlight. The materials involved in this change are water and carbon dioxide, which is always present in the air, much of it the result of the breathing of men and animals. This is a model of a molecule of carbon dioxide. It contains one carbon atom and two oxygen atoms. You remember that a molecule of water has two hydrogen atoms and one oxygen atom. Water enters a plant through its roots, and the water molecules are stored in the leaves. Molecules of carbon dioxide pass into the leaves from the air. Inside the leaf, in the presence of the green coloring matter called chlorophyll, and with energy from the sunlight, a chemical change takes place. 6 molecules of water and 6 molecules of carbon dioxide combine with each other to produce a molecule which contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. This is a molecule of sugar. By this chemical change, which is called photosynthesis, plants produce food. The plants use this food to grow. And we use it too. When the sugar molecule is produced, there are 12 oxygen atoms left over. They form 6 molecules of oxygen. These molecules are not wasted. If we look at a plant growing underwater, we can see bubbles. They are caused by the oxygen passing from the leaves back into the air. Once in the air, the oxygen can be breathed again. In a chemical change, the atoms from the molecules of 2 or more kinds of materials combine to produce molecules of entirely different materials. Many chemical changes give off energy, while others must have an outside source of energy, such as the sun, in order to take place. New materials are formed, but no material is lost in chemical changes. Wherever there is life, chemical changes are taking place.